Welcome back children, I am Qnos here. We are discussing miscellaneous exercise of chapter 1 relations and function, question number 3. The question says if f of R2 or real number to real number is a function is defined by f of x equal to x squared minus 3x plus 2. You need to find f of x. It's going to be a very easy question children. Now let us take whatever is given, x squared minus 3x plus 2. Now you need to find f of x. That means within f you have to substitute x squared minus 3x plus 2. Now see this question, f of x, wherever you have x squared minus 3 into x plus 2. So whatever argument you have to square it. Now I have this bigger argument. So I will write x squared minus 3x plus 2 the whole square minus 3 times x. Whatever you have to write 3 times. So 3 times x squared minus 3x plus 2 and remaining plus 2 is there. That's it children. Now this is a plus b plus c the whole squared formula. 9th standard. A plus b plus c the whole squared equals a squared plus b squared plus c squared plus 2ab plus 2bc plus 2ca. That's it children. You can very fast you can do. A is x squared, b is minus 3x, c is plus 2. Substitute that a squared, which means x squared the whole square, b squared minus 3x the whole square, c squared is 2 squared plus 2ab, 2 into x squared into minus 3x plus 2bc, 2 into minus 3x into 2 plus 2ca, 2 into c is 2 and a is x squared. Okay children, now remaining terms you have to take this negative inside. So minus 3x squared plus 9x minus 6 plus 2. Correct children? Minus 3x squared plus 9x minus 6 plus 2. I am erasing this formula. I hope you would have copied this formula and you also remember that. Now we will complete the question now. X squared the whole square x power 4 plus 9x squared plus 4 plus into minus is minus, so minus 6x cube minus again 3 2s are 6 2s are 12 minus 12x plus 4x squared minus 3x squared plus 9x minus 4 minus 6 plus 2. Now we can simplify x power 4, no other 4 terms are there. Then we have x cube 6x cube. Now x squared 9x squared plus 4x squared minus 3x squared. 9 plus 4 is 13 minus 3 is 10. So plus 10x squared. Okay children. Now minus 12 plus 9. So minus 3x. Next plus 4 and minus 4 they get cancelled. So any other terms left? No. So this is your f of x children. This completes the solution. You have to remember only a plus b plus c the whole squared formula. Thank you. Welcome back children. We are discussing miscellaneous exercise 4th problem. The question says show f defined from R to x belongs to R where x lies between minus 1 to 1 defined by f of x equals x by 1 plus modulus of x belongs to R is 1 to 1 and onto function. We have to show that f is 1 to 1 function and onto function. Now this f of x can be written in 2 ways because we have a modulus x always returns a positive value. So we will write like this 1 plus x when x is greater than or equal to 0 and x by 1 minus x whenever x is less than 0. Why it's like that children? When x less than 0, tell me one number of x less than 0, we'll take minus 1. Okay, now here we have taken 1 minus of minus 1. What will happen? 1 plus 1, this changes to a plus sign. So it becomes positive. Do you understand? That's why x by 1 plus 1. You can think it of this one is negative sir. Let it be. We are discussing only about this one, this modulus x. Here you can see plus x, I have taken negative x, 1 x is less than 0. So less than 0 means all negative numbers. To change the negative numbers to positive, we are using a negative n. Here no problem at all because it is greater than or equal to 0. So all positive numbers will be there. So this you should understand. So whenever you see modulus of x, I have plus x and minus x. You may have a doubt, sir, what about the numerator? Sir, numerator is just an x. So there is no confusion about that. Okay, only the denominator you have to see. Now children, you see when I put x a positive number, f of x is positive for this case. Because this is a positive number, no negative. 1 plus again a positive number. There is no confusion in this. Here, negative, if when you put x negative number, this is negative, I will say one number, negative 2. Negative 2, 1 minus of minus 2. So you will have minus 2 by 1 plus 2, which is negative number. Okay, so f of x is negative for this function f of x is positive for this function. Why I am telling this now is when you are finding onto function, you need to remember that. Let me see how far you are recalling this point, whatever I said now. Now I am going for one-to-one function. Okay, children. Now let me take two numbers x1 and x2. One is positive and another is negative. Let us see what happens. x2 is negative. Now children, we know as usual we will start images are equal and we will be proving that elements are equal. Now let us see x1 is positive. Positive means what you should take? X by 1 plus x. Negative means you have to choose x by 1 minus x. So you have x1 here, you have x2 here. Cross multiply now. x1 minus x1 x2. Here x2 plus x1 x2. You cannot cancel anything. Bring everything on one side. So x1 minus x2, or you bring that 2 times x1 x2. See children, x1 is a positive number. It is greater number, right? x2 is a small number. So this side it's going to be positive. Do you understand? This is a positive number, this is negative number. Positive number is always greater. So in this side you will be having positive. Whereas here x1 is positive, x2 is negative. Here you will have negative. So positive is not equal to negative. So x1 is not equal to, will never become equal to x2. Do you understand? You should think of a number. So 5 minus negative number, this side will be positive. 5, for example, I take 5 and minus 1. So what you will say? 5 minus of minus 1 is 5 plus 1 is 6. You go on the other side, 2 times 5 times minus 1. So you have minus 10. They are not equal. So it's not possible. Okay. So one positive and one negative is not possible. Similarly, x1 positive, x1 negative and x2 positive is also not possible. You can write similarly. It's also not possible. It's also not possible. So, what is the final conclusion? Either x1 and x2 should be positive, both should be positive, or x1 and x2 should be negative. Both should be positive or should be negative. If one is positive, one is negative, we are saying that it is not possible. So let us take when both cases we are right. When x1 and x2 are positive. When x1 and x2 are positive. Now let us start. F of x1 is equal to f of x2. What is when positive? x1 by 1 plus x1. x2 by 1 plus x2. Now you cross multiply. x1 plus x1 x2 equals x2 plus x1 x2. Subtracting x1 x2 on both sides, this gets cancelled. You get x1 equal to x2. Therefore f is 1 to 1. Correct children? See how easily it is done. So it has to be both positive or it has to be negative. Now we have to do it for negative. So we are going to take x1 and x2 both negative now. We'll do it faster. Easily we can complete x1 and x2 or negative. Tell me now. Yes, negative means x by, yes, x1 by 1 minus x1. You are right. x2 by 1 minus x2. So simplify. x1 minus x1 x2. x2 minus x1 x2. Now add x1 x2 on both sides. Gets cancelled. x1 equal to x2. You have proved. Therefore f is 1 to 1. The same way you have to show 1 to 1. On to also you have to show positive cases as well as negative cases. Okay children. Now to prove on to. This completes 1 to 1. 1 to 1 seem to be always easier, right? On to little. Let us start. To verify on to. To verify on to. Okay. When y is or when f of x is positive or y is positive. So f of x is positive means you have to take this formula because in this case only f of x is. I told you to recall that, right? So this is positive. Very good. F of x is positive. So this function has to be taken. Let us take it as f y is equal to y, x by 1 by x. Solve this for y. X y equal to x. Yes. So we have to solve for x, right? So y is equal to x minus xy. Take this x out. You will have y. So y my 1 minus y is equal to x. We know this is the inverse. We know this is the inverse. If y is greater than f of x is positive. Now how to prove that? again you have to substitute in f of x. We need to substitute in f of x. What is f of x actually? X by 1 plus x. X by 1 plus x. In this you need to substitute this y by 1 minus y. Now tell me y by 1 minus y divided by 1 plus y by 1 minus y. Simplify this. Now what you will get when you simplify? My board is small, so I need to erase and write it. So you need to wait for a fraction of a second. Now let us continue. Y by 1 minus y. Take LCM. 1 minus y plus y divided by 1 minus y. This 1 minus 1 minus gets cancelled. Minus y plus gets cancelled. Y by 1 which is equal to y. So you got f of x is equal to y, which means f of y minus y. So when you get y, what do you know? Yes, for every y belongs to y, the codomain, there exists an x belongs to x, the domain, such that f of x equals y. What is this actually? This is a statement for f is onto function statement. Very good. So we got an y here. So we have proved f of x equal to y. Therefore, f is onto function. Okay, children, we have proved for f of x equal to positive. Now what I should do? I should also show f is onto function for y, f of x is negative. So I am going to make small changes here. What function we have for negative? Yes, f of x is negative. What is f of x, children? Can you help me out? Yes, 1 by 1 minus x. Sorry, x by 1 minus x. Thank you. Now we'll take this as y. Y equal to x by 1 minus x. Now cross multiply. Y minus xy equal to x. Y equals x plus xy. Remove that x out. 1 plus y. So y by 1 plus y is equal to x. So this is the inverse. To prove that this is the inverse, again you have to continue with f of, substitute in f of x. F of y plus y by 1 plus y is equal to x by 1 minus y. So x by 1 plus y divided by 1 minus of y by 1 plus y. Okay, children. Now similarly, we have to take LCM. Y by 1 plus y divided by, take LCM, 1 plus y minus y divided by 1 plus y. Okay, children. Now strike out 1 plus y, 1 plus y gets cancelled, plus y minus y. So you got y. So f of y by 1 plus y is also equal to y. Therefore, f is onto function. When y is, f of x is negative also, you have f is onto function. So we have proved 1 to 1, hence proved. So what you have to remember, children? Only the modulus. Whenever you see modulus of x, you should know that you have to split into two. One is positive x, one is negative x. This is for x greater than or equal to 0. This is for x less than 0. This is what you have to remember for these sort of questions. Because this x should be always be positive. Less than x values will take negative will become positive. This is a small logic behind this modulus of x. I hope this completes and you understood this question. Thank you.